We're now going to walk through an example where we'll use Newton's method to approximate a root. In this example, we're going to use Newton's method to approximate the square root of 2 until successive approximations agree to 4 decimal places. Just to make things easier, I went ahead and wrote down the formula that we're going to be using for Newton's method. To approximate the square root of 2, we need to start by letting x equal the square root of 2. We're then going to square both sides of our equation so that we get an equation that doesn't have the square root of 2 in it. The equation that we use Newton's method to solve is the equation f of x is equal to 0. So we have to get our equation in the same format as this equation. So we're going to subtract 2 from both sides, and we get x squared minus 2 is equal to 0. So we can say that f of x is equal to x squared minus 2. Let's now notice that in our formula for Newton's method, we have an f prime. So let's go ahead and let's find f prime. F prime of x is 2x. We can now write down the formula for x sub n plus 1. That is our approximate solution. Looking up at our formula on the right, it's equal to x sub n minus f of x sub n. So for our problem, that is x sub n squared minus 2, all divided by f prime at x sub n, and that's 2xn. Sometimes when you're using Newton's method to solve an equation, you are given an initial approximation, and then sometimes you're not. In this example, we are not given an initial approximation, so we have to figure that out. So let's just write down that we need to find x sub 0. X sub 0 is an approximation to the square root of 2. So let's go ahead and let's do this. Let's write down that the square root of 1 is equal to 1. And then let's think about a number that we know the square root of. That next number would be 4. So let's write down that the square root of 4 is equal to 2. This means that the square root of 2 is going to be between 1 and 2. So I think a good approximation to start with would be halfway in between. So let's let x0 be 1.5. Now we can go ahead and write down what x sub 1 should be. That is our next approximation. Looking right up here at this formula, x1 is going to be x0 minus x0 squared minus 2, all divided by 2x0. Now what you have to do is take this formula, put it into your calculator, and let x0 be 1.5, and you end up with 1.4167. Let's go ahead and let's highlight that, and then we'll go back and highlight x0. x1 and x0 do not agree, so we have to keep going. So let's find x2. x2 is going to be x1 minus x1 squared minus 2, all divided by 2x1. You put that into your calculator, and we get an answer of 1.4142. Now we compare x2 to x1. Those are similar, but they're not exactly the same, so we have to keep going. x3 is equal to the same type of formula. I'm not going to write it down. You just take x2, plug it into the formula, and here's what you get. You get 1.4142. Notice that this solution is the same as x2. So that means that this solution is accurate to within 4 decimal places. We can then say that the square root of 2 is approximately 1.4142. Just a quick recap. If we go back up to the top, here's what I think you need to remember. I think the hardest part of this problem is creating this equation right here. So just remember, you start with x is equal to square root of 2, you square it, and then you pull everything to the left.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.